Good afternoon. Today's recording is going to cover F5 IngressLink deployed in EKS Anywhere. You might ask me, what is EKS Anywhere? And so EKS Anywhere is an offering from Amazon that is coming, I believe it's coming later this month. And so Amazon EKS Anywhere is a new deployment option for Amazon EKS services. And so this allows you to build or deploy a Kubernetes cluster on your premise, right? And so in my environment, I deployed a EKS Anywhere cluster on VMware, and I created a couple of EKS Anywhere nodes, which is ultimately, at the end of the day, Kubernetes nodes. And I integrated F5 IngressLink. And so F5 IngressLink addresses really the modern application delivery architecture, right, to scale. So IngressLink really takes the best of breed. It defines them, and it puts them together. So it really defines the best of breed of your big IP with integration of automation through CIS and Kubernetes, as well as your Nginx Ingress services using Nginx Ingress controller to scale out and work with the pod architecture within Kubernetes and provide the best of breed there. You could almost treat this as like multiple personas kind of working together. Your big IP administration or administrator personas working with big IP and CIS to forward all ingress traffic from your on-prem premise, your on-prem environment, doing some edge services from the big IP into Kubernetes and handing them off to the Kubernetes Ingress controller, which would be administered by your Kubernetes administrator or by your application developer, which would then go ahead and create your resources for coffee and tea services. So this demo is really going to demonstrate the capabilities of that architecture. I already provided some previous demos and some user guides for how to deploy F5 IngressLink. I'm not going to cover too much about EKS Anywhere. I'm going to leave that up to the Amazon folks to talk a little bit about how to deploy EKS Anywhere. They've got a document that you can follow to build out your cluster, to add nodes to your cluster, etc. I'm sure you'll be able to find all of that from the site once this becomes available. So the first thing that you need to do with the IngressLink is deploy the fundamental components like deploy CIS and deploy Nginx Ingress controller. The two controllers are independent, but IngressLink has cross-team development. So there's development with CIS and development with Nginx Ingress controller, specifically around the common CRD that we're going to create between the two. So CIS's purpose here is really to automate big IP with the pool members of the Nginx Ingress controller. And the Nginx Ingress controller would then farm out that traffic to the deployment of pods that are created by the DevOps user. So the DevOps user can go ahead and create, remove pods, etc., and it really won't affect the CIS automation of big IP at all, as long as there are Nginx Ingress controllers available. In this here, I have three in this diagram, and I'll go ahead and show you what's in my environment. So as we scroll down through this, the first is to go ahead and to install CIS. You can just follow my guide. You can download my repo. So once you've deployed CIS, you can make sure that CIS is running by doing a kubectl get pod, and we can see that CIS is running. So you can log CIS if you want, but at this point, just to make sure that CIS is running. Once CIS is running, it's able to communicate with big IP to get versions of the API, etc., etc. That's doing some health checks as well. The next would be to create your Nginx controller installation. So this is the Nginx Ingress controller configuration. So install the schema. There's a couple of files. Just follow the user guide to help you install these files. As part of the service, in the service, we have defined a readiness port. The readiness port is required because CIS is going to use this, or is going to use this to check the readiness of the Kik instance. Actually, Big IP monitors this instance. So let's go ahead and I've already deployed this, so let's go ahead and check the Nginx piece. And so you'll see here, I've got 4 Nginx instances running in this environment. That is just based on my Nginx Ingress controller configuration. I have 4 replicas. It's going to create 4 replicas. And so the next piece would be to create the resource definition. So the resource definition is really important, because the resource definition right here is going to define the public IP address that is going to ingress all traffic to this EKS cluster. So this public IP, you think of it as a virtual IP address. That's the IP address that is provided on the big IP that is then a FQN in DNS. In my example, it's cafe.example.com, and it's specifically going to handle coffee and tea pods, right? At this point right now, you can see that the application is down, and the reason for that is because the big IP doesn't have any active traffic. And so what we're going to do at this point is we're going to go ahead and create this CRD. Now, this is the benefit of EngressLink. EngressLink is simplifying the configuration between CIS, Nginx, and Big IP. And so the simplification makes it easier to integrate these 2 components. And there's a lot more simplification coming. And so that's one of the biggest reasons why this environment is kind of important. So as we log into the Big IP, we can take a look at the active configuration on the Big IP. Let's change to the EngressLink tenant. As you can see, there's no configuration on the Big IP. So let's create the virtual server. So we're going to do a kubectl create -f and the virtual server. And if you want, we can simply just do a cat on this virtual server. We can take a look at it. So you really see it's about 12 lines here. The most important being the virtual server IP address. We're using the IRO proxy protocol. Everything else is pre-allocated, predefined, pre-coded. So all you need to do is just really create this one simple virtual server. And if you take a look on the Big IP, that virtual server CRD has now created 2 instances, both port 443 and port 80. It has also created 2 instances with regards to the pool members. You can see that there's 2 pool members in this case. If we take a look at the nodes, you're going to see that there's 2 nodes right here. You might ask, why is it 2 nodes? And the reason is because we're specifically using a node port implementation. So because I deployed a 2-node cluster, in this case I have 2 nodes, so all my traffic is going to the node first before it goes to the Nginx Ingress controller. That's just how I deployed this. Node port is quite common. If you didn't want to use node port, I am going to create a video for CNI integration coming up next. If you wanted to see the 2 nodes, you can see here are the EKS nodes. I have 2 nodes here. Traditionally, normally we wouldn't run, we would ignore the master node. And so I'm going to create another video of using node port where I'm ignoring the master node using a node label. Just look out for that. You can see here are the 2 IPs, 26 and 27. And that's what you see, 26, 27. If I go ahead now and connect to this application, let's go take a look at T. You can see here I have 102, 245, and 12. So if we look at those pods, if I do a kubectl get pods, I can actually see that I am actually accessing the T pods, and that's why I'm getting load balance. So all the traffic in this environment is coming into the big IP. The big IP is sending it directly to the node via node port, which then gets sent to one of these 4 Nginx ingress controllers, which forwards it to either coffee or tea. It basically fans it out in this instance. So it's big IP to node, node to Nginx ingress controller, which is then fanned out through coffee and tea. So if I change this to coffee, it would get reload balance to coffee. You can see there 106, 122. So what we can do is we can do a kubectl. We can describe this pod. Let's describe the top pod. We'll describe this coffee one here. And we can look at the IP address of this. And you can see it's 106. And so 106 is up here, 106. So that's the actual server itself. So you can see once you've created the EngressLink virtual server, then of course you would deploy the cafe application. I've given you how to deploy the cafe application here, and of course this is what you're seeing. The Nginx, there's the 106 in this case. So to recap, this demo is displaying F5 IngressLink. IngressLink is best of breed of both F5 and CIS, as well as Nginx Ingress Controller that is deployed in a EKS Anywhere cluster that we've deployed in our lab here, running on top of a VMware ESX environment. And so in this instance, we just deployed a small cluster just for the testing purposes. And so the purpose of using the F5 is that maybe you would already have the F5 there. You can enable some additional services if you want, such as WAF, maybe some firewall services to basically front end or WAF or protect your Kubernetes cluster. Once you've then forwarded the traffic to the Ingress controller, it's forwarded to the pods. You can run additional type of security at that point. Thank you very much. If you like this video, please like and subscribe. There will be a few more coming and lots of other interesting videos around F5, CIS, automation orchestration. Thank you.